Assalamu alaikum. My name is Hamza Masood and my registration number is 16T49. I am a student of UT Texla Telecom Department. Let's start our lecture. In our lecture number 9, we'll study about the inverse Fourier transform. In my previous lecture, I have taken the signal x of n, this, and then हमने फिर इसका DFT discrete time Fourier transform लिया था and we get this signal. And now we will study a few more terms like frequency resolution, that is delta f is equal to f of s divided by capital N, and the inverse discrete time Fourier transform. Now I have taken this signal and this is the Fourier transform of this signal, and the frequency resolution, here we not have given the sampling frequency, so we let the frequency let fs is equal to 16,000 and delta f we get 16,000, and here we have 4, so we get 4,000 hertz frequency. So if we draw this graph, we will get amplitude x of k. At 0 we have 0, and at 1 we have 2j, and this is, let's suppose, 2 0 1, and at 2 it has value 4, and again at 3 it has value 2. This is the graph of in frequency domain of this signal. Now let's suppose we apply a high frequency filter and extract this frequency. Let's suppose we say that notch out the frequency which is greater than, this is 0, this is in term of k. If we write this in term of frequency, we will get 0, and now at 4,000 we will get 2, and at 8,000 we will get 4, and at 2 we will get 12,000. Now we want to notch out frequency greater than 7,000, so we will get the signal capital X of k is equal to 0 2j 0 minus 2j. This 4 becomes 0 here because we have notched out the frequency, high frequency component greater than 5,000 or 6,000, so we will get this signal. And now we will take the inverse discrete time Fourier transform and get x of n and see what difference it make. We have x of n inverse discrete time Fourier transform, we get the signal, we have formula 1 over capital N summation n is equal to 0 to capital N minus 1 capital X of k into e raised 2 pi nk divided by capital N. Now I have expanded this formula, this summation sign I have expanded, and I have put the value of capital N. Now we'll find x of 0 when n is equal to 0. We have 1 by 4. X of 0, we have 0 here, 0, and all time become 0, plus x of 1, I have 2j, and this term e power 2 pi, and we have 0, so this term become 1. Now plus x of 2, again we have 0, so all time become 0, plus x of 3, we have minus 2j, and here we have 3, and n is 0, so this term become 1, so we have this, and again by simplifying what we will get, 0. X of 0 is equal to 0. We will get x of 0 is equal to 0. Now we find x of 1, which is equal to 1 by 4. We have now n is equal to 1. This whole term becomes 0 because x of 0 is 0. Plus x of 1, we have 2j, and here we have 2. Now n is equal to 1, so we'll get 2 pi by 4, and by cancelling these we get pi by 2, and pi by 2 we know that it is j into j, plus get, because x of 2 is 0, so we have written 0, and now again we have x of 3 minus 2j, and here we have 3, cancel this, 3 pi by 2, 3 by 2 we have minus j, so we will get 1 by 4. Here we get minus 2 because this is j square and it is minus 2, and here we have 2j square, again we have minus 2, so we'll get 1 by 4 into minus 4, and we get minus 1. Again we'll find x of 2, which is 1 by 2 into, the first term is 0, second term we will get, we have 2j, and now I have solved the problem, and I have find the inverse discrete time Fourier transform, and I have get the signal x of n is equal to 0, minus 1, 0, 1. And if we compare this signal with our previous signal x of n, we have 1, minus 2, 1, and 0. So in this signal we have greater transition, we have from 1 to minus 2 transition, and minus 2 again 1, so we have higher frequency component in our frequency spectra. And now in this x of n we have lower transition from 0 to minus 1, and minus 1 to 0 to 1 again, so the transition become less because we have notched out the high frequency component in our frequency signal. So this is all about today lecture. आज का हमारा लेक्चर कंप्लीट हुआ, मिलते हैं नेक्स्ट टाइम। अस्सलाम वालेकुम।